Fly me to the moon and let me play among the stars. Well, everybody, I hope you are enjoying our trip to the moon in LaVidConf. Now we will have an amazing panel with some of the top minds in the crypto space, the people who has been building the technology and moving the technology forward to solve the different problems that Bitcoin and later blockchain platforms, decentralized blockchain platforms, have been facing to scale, to provide different needs to take these technologies to mass adoption. So without further ado, I want to receive with a big welcome to our panelists to discuss what is the second layer. What is beyond blockchain, beyond the base blockchain layers? And for that we have Adam back from Blockstream. We have Jordy Baylina from Ethereum. Then we have, Ola. It will be tough. You will have to help me with that. Olaoluwa.
Olaoluwa, or you can say roast beef or Olaoluwa.
I did it right. I always think I will say it wrong. Olaoluwa from Lightning Labs, and also, of course, Sergio Lerner from RSK. As I said, people who has been driving the innovation and the growth of these decentralized technologies for many years now, and doing great contributions. So I think to start this, I would love each of you to introduce yourself and share with us what are you doing or have been doing on the layer 2 space. I know you have been working on the layer 1, and many of you have been on the layer 1, but what have you been doing on the layer 2 space, and share a little bit of what you are doing. So maybe we can start with Adam, and then we'll move.
So yeah, Blockstream's been doing things at different layers. So we do some layer 0, like satellite infrastructure to send blocks of Bitcoin transactions around, and physical mining. And then obviously layer 1, Bitcoin wallet, the green wallet, more recently Aqua. Layer 2, we have 2 things going on. One is we're one of the implementers of the Lightning protocol. There are 3 or probably more at this point independent implementations working on a combined spec. So we have a team working on that. And then we have Liquid, which is a sidechain, so a different kind of layer. And we can talk about how those layers combine later.
Amazing. Olaoluwa, do you want to share with us about Lightning, what you are doing at Lightning Labs? So.
Okay, sure. And by the way, you can just call me roast beef as well if that's easier for you. Yeah, so Lightning Labs, obviously we kind of work on Lightning, along with Blockstream and async around the companies as well, like Square Crypto and things like that. So obviously we kind of do things at layer 2 on Lightning itself. We also make something called Lightning Loop, which is effectively kind of like a layer, a bridge between layer 1 and layer 2. So for example, Lightning Loop lets you kind of send off chain to on chain basically, or the other way around. So you can actually have some cool things where I can make an on chain payment for my Lightning wallet purely without closing any other channels, and the other way around as well, which is pretty cool. Then we make something called Lightning Pool, which I consider kind of like a layer 3, given that shadow chains are kind of like abstracting away from outputs, for one layer. We can have something application on top of that as well. We'll probably talk about kind of like definitions a little bit later. But that's what we do. We kind of work on layer 1 and layer 2, primarily kind of focusing on layer 2, at the same time trying to help people move from layer 1 to layer 2, and the solutions in that domain as well.
Here almost collapsed. So I'm going to ask you to speak slower because
what collapsed? What collapsed?
Because we have real-time translation. Because this is
okay.
This is broadcast in Spanish and English at the same time. So
gotcha.
If you can speak slower, I think because okay, I see the face of the translator here, and then he's like saying,
yeah, I mean, I guess help,
like, please help.
The coffee's just hitting for me, so I just woke up, so coffee's just hitting. But I'll calm down a little bit.
Thank you very much. Thank you. The translator will. So, Jordy, can you share a little bit of what you have been doing in layer 2 space within Ethereum?
Yes, well, mainly I'm just Hermes, which is a ZK rollup, and we are launching in the upcoming months. We are going to launch a ZK rollup. in the last years, I've been working in zero-knowledge tooling. I'm the owner of Circom and Snark.js, and mainly what we're doing is just taking on this technology and building what's understood as ZK Rollup. ZK Rollup is like a kind of side chain or a sub chain that runs in Ethereum. And well, the idea is that you can process like 2,000 transactions in a single layer 1 transaction, and you can compress a lot and roll up them a lot, and so you can scale and you can put a lot of transactions in the layer 1 or that layer 2.
Thank you very much. Sergio, can you share a little bit of, because I want to know, yeah. I'm not very aware, but I would love to know about it.
Okay, so I'm involved in, first of all, I consider RSK a second layer of Bitcoin in a sense, even if there's a different technology, but the same crypto asset. So I consider it really a second layer of Bitcoin, one of the second layers of Bitcoin. So personally, I'm very, very much involved in RSK network, the protocol, improving the two-way peg, the security and usability of the two-way peg. But also for the last 3 years, I've been involved in improving the on-chain layer to scale more than a normal blockchain, keeping the main blockchain proposition, but still scaling with transaction compression, batching, parallel processing of transactions, signature aggregation. So making the most of the base layer. But I'm part of the IOB, and my team, the research and innovation team, has finished and is soon to put in production an enveloping system, which is a meta transaction system, which also has some sense. Because it does transaction aggregation, then it also contributes as a second layer payment network in a sense. Okay. And finally, the organization has the Reef protocols, which include Lumino payments, which is a payment channel network. So I'm involved mostly in RSK, but also giving support to these other projects that are happening at the IOB Labs.
Actually, what we have is on one side we have, because what we can see is that second layers can take a lot of forms. No? So they can serve different purposes, but also take different forms, because I think payment channels are peer-to-peer agreements established that then are settled on a blockchain layer. So peer-to-peer agreements that then are enforced on the blockchain layer. Same that happens with ZK rollups or these commit chains, where you are consolidating a lot of transactions and then settling on the blockchain layer. But then what Adam is doing with Liquid and Sergio has been doing with RSK blockchain are second layers that are blockchains themselves. So it's a full blockchain that is it's a side chain. So it's pegged in a way by the asset at least. So they share the asset with the primary layer. Well, in the case of Lightning, that's also the case. But so we can see that second layers can take many forms. So what is the definition of a second layer? No, of course, the easy definition is another layer on top of a base layer. No, but what can we define what a second layer is, or what its purpose is?
That does the same functionality. Obviously, there will be different security assumptions, but if you can do the same but cheaper, and of course you can be half federated, but that is essentially a central layer. If your base layer performs smart contracts, then your second layer, you can have a second layer of smart contract processing also. So
from your perspective, the function of a second layer is more about the scaling and lowering operational cost.
Totally.
Okay.
Yeah.
What about you, Jordy? What do you think about that definition, or how do you see the second layer?
Well, at the end is a definition. I agree very much in the definition that Sergio made. But yes, it's the idea of the layer 2 is for me it's a layer that's using the properties of the layer one, the consensus properties, and so it's using the layer one to build something that's more scalable in terms of number of transactions, in terms of price, in terms of usability. So it can go it can go faster and with better throughput or with better latency, with better, so in general with better properties. But for me, it's important to say that it uses the layer one, so it uses the basic layer.
And what about you, Ola? What do you think about the?
Yeah, I mean, like, I guess, like, I wouldn't kind of like attach kind of like the like cheapness scalability, like kind of like the way Sergio does. I guess for me, kind of like second layer is anything that like actually like abstracts over kind of like base Bitcoin itself. And like by abstracting, I mean kind of like in kind of like a kind of like a CS sense, and that you can kind of like hide into traditional layers, and kind of like have something on top of that. For example, like Lightning abstracts over like what is just effectively like a multi-sig, right? So and then the like channel just multi-sig in the chain. So therefore now we have like abstraction over that. Basically, make payment channel between two individuals. That's like a payment channel doesn't really exist at the base level. It kind of like exists in like our minds or in the software basically, because the base layer basically just sees like an output being spent, doesn't see any transactions, right? So to me, it's anything that abstracts over that. So that's why I feel like it's a little bit easier to find like layer on top of that, because you basically have like another layer of abstraction. For example, like we have something called like Lightning Pool. It's kind of like a way you can kind of like buy and sell the channel leases built in something called a shadow chain, right? A shadow chain kind of like abstracts over a base like UTXO, kind of like something we have a lift UTXO. We can abstract over that further to basically create kind of like the account in this like effectively like a batch exchange itself. So for me, it's basically anything that abstracts over a base layer UTXO and then falls back to the prior layer. So you can basically kind of like chain that independently. So I feel like the scalability benefits are kind of like typically a lot of people do it. It's kind of like contracted for, but I feel also like you can have additional kind of like application level advantages basically by kind of like having a slightly different model that you can build the application on top of, which way kind of like what a shadow chain does. So I wouldn't attach like the scalability too much to me. It's just more about kind of like abstraction, what you can do with that new abstraction basically, because at the higher level you basically have like simpler assumptions. For example, like, when you have a payment channel, you don't really have to worry about on-chain fees. You don't have to worry about confirmation basically, but you kind of like have some different trade-offs, because at the end of the day you still fall back to kind of like what the base layer is.
So for you, it's not.
I think.
Yeah.
Oh, sorry. Go ahead. Yeah. I mean, I think.
Please go ahead, Adam. Yes.
Yeah, you typically, at least with today's technology, have to make some trade-off where something gets worse compared to the main chain. So typically there's a security trade-off, and then you're trying to get something in return. So that could be sort of modularity. So I think the sidechain you could think of as a kind of extension mechanism with security isolation. So if the sidechain suffers a consensus failure, that won't affect the main chain directly, where other forms of on-chain extensibility tend to be fragile so far. And yeah, I mean, so it could be to adopt, I mean, you can think about Lightning as a higher scalability model with a security trade-off, right? It involves some increased hot exposure, and as a result, you get cheaper, faster transactions. Another model is the sidechain, which is, we've got two people on the panel who are talking about sidechains, RSK and Blockstream's Liquid network. And there it's about adding different functionality. And some of the functionality is maybe not even high risk. It's just that the main chain, at least for Bitcoin, tends to want to focus on doing one thing and doing one thing well. So some of the things on Liquid are confidential transactions. That's a fairly low risk piece of crypto technology, but a little bit, slightly large. So that's kind of anti-scalability feature right there, but for privacy advantages. And then support for other assets, and in the future, enhanced smart contracting. So we also have a different piece of technology called Simplicity, which actually predates Blockstream in its inception. And it's usable for layer 1 or layer 2, so it's usable on the main chain, and we have a developer release that works on Bitcoin Reg Test and also within Liquid. So that's the sort of general programmability and extensibility layer, extensibility, so a new script language for Bitcoin.
So we can say that it's not only about scalability, but it's also about functionality, and not necessarily because that functionality, it's better or less secure or more secure. It's mostly about delegation of responsibilities, that each layer will have like a clear responsibility and focus on one security model and one certain security assumptions So,
Yeah.
so we
mean,
can say that it's not only about scaling or lowering costs, but also about extending functionalities or delegating certain responsibilities that you don't want to have on the primary chain, something like that.
I mean, I guess we could say it's similar to other networking stacks. So TCP/IP, GSM networks, everything going from the base layer up to a protocol layer typically has multiple mid and high level protocols and has a clearly defined interface and dependency on the base protocol, but then the different layer twos could be specialized for different things. So, some of the things that go into Liquid are, arguably a bit big, so they're not good for scalability, let's say, confidential transactions, or maybe they still have some experimental risk. Sometimes you want to try experimental things, which people would like to see in Bitcoin, but are currently too high risk. And so, for example, early versions of some Bitcoin things were in the Liquid layer 2 first, and later came. And I think the security firewall or sort of safety boundary is a key part. So that if something goes wrong in layer 2 land, it generally doesn't affect layer 1. And the other thing the other differentiator actually is layer 2 tends to be permissionless. You typically don't need a change from layer 1 to do it. So you can have different protocols and different layers that compete for functionality without the kind of consensus fork risk of making changes in layer 1, which is a higher assurance target.
Well, yeah, that's true to a degree, unless you need new things to make your layer 2, whatever it is. So,
yeah.
But,
so there, we can see as layers also as a security in depth architectural design as well. So you also, as you said, Adam, the different layers we go adding and have different, the delegation of concern also protects the network as a whole, no? So we are using foundational layers and then building different connected protocols or additional blockchains and layers interconnected that will also create more anti-fragility for the ecosystem as a whole. So that could be another point of view from this. Do you agree? I think, Sergio, you wanted to add or comment on something else.
There is a key distinction between a payment network and a cryptocurrency network or a monetary network, I would say, that needs to ossify much sooner than if I created a payment network just to move money, because that is a long store of value. So the properties that we require for this layer 1 would be Bitcoin, is not only is decentralized and secure, but it needs to be simple, right? So scalability and cost, these are second order requirements. The need that the base layer is simple enough that there are thousands or tens of thousands of people being able to audit that code and audit the monetary supply. It's much more important than scalability at the base layer. That's how I see the need to ossify Bitcoin much sooner than if it was just a payment network.
Ossify and also reduce the surface of attack, no? To keep it simple, to keep the if you want the social contracts, it's programming contracts, but the basic contracts of the network very simple, so they can be audited, they can be enforced, and you have more eyes put on how the protocol behaves. And that will take me to the uncomfortable question, because that was a long-term debate in the Bitcoin ecosystem. But why not? I think we already answered this, no? But why not do all these things, expand and extend everything? I mean, on the first layer. I mean, I think partially you all already answered, that we don't want to put all these for security reasons, but there are other reasons why, doing all these things that we are doing on second layers should not be put on the first layer. I mean, do you see other things? I mean, how it impacts decentralization, cost of operations. I mean, there are other areas where there are trade-offs of doing this all in one layer. Maybe Jordy, you can. You can
Well,
start now.
at the end, consensus is expensive. So when you have thousands of computers in the world that needs to agree in something, this is expensive, and the quantity of information that can be consensuated is limited by the protocol itself. You can do this protocol better. You can do it. You can grow it, but it has a limit. It has a limit actually with the computing power of the nodes at the end. And the naive way of doing this is limited. Ethereum, for example, is like about 10 times more scalable with some other problems, but that's a limit there too. So it's not, you cannot go beyond that just doing what we are doing. So that's why we need this second layer.
Do you want to add, Adam, or
yeah?
something?
So I think hypothetically, if some new technologies solved the layer 1 scaling problem, so let's say a very efficient scalable SNARK mechanism. I mean, that's not the entire problem, but it would clearly be a very interesting building block to scale a blockchain. I think there's still sound reasons for having separate layers. So if you think about, let's say, an operating system kernel, there's a viewpoint that you should use a microkernel, which for improved security. You generally don't want to put too much code in one security boundary. The blockchain is kind of the core for your security, but the consensus behavior is kind of like designing a crypto system. You have to be very careful and cautious about changes, or it can have unintended side effects. Slight difference in interpretation on different architectures can result in a network fork. So I think the idea is generally you want to sort of perfect that, minimize it, and test it very well, and then be able to depend on it and build other things on top.
Excellent.
And then, I just want to add one point, something that Sergio said as well, earlier, and that, I think you expressed you kind of want, typically simplicity on the base layer. But I guess in my opinion, you want the simplicity, but at the same time, you want the ability to kind of express what you need in layer 2. So, for example, obviously, in order to even make Lightning itself, we had to add certain things to Bitcoin. We needed things like CLTV, maybe now we need even no input as well. So I think it's important to have simplicity in base layer, but at the same time, I feel like base layer needs to be expressive enough to basically allow people to create higher level applications on top of it. I think we always need to get back to that the same thing, kind of permissionless innovation, basically. Now, the base layer should basically have the primitives necessary to allow individuals to basically build these new primitives or new applications without really coordinating with other individuals, and or need to make a change every single time we have a new application that we need to make, right? So I think that I'm kind of identifying with the whole ossification thing, but I still think that we need to make sure that individuals have basically what they need the base layer, so we don't have to continually do a fork every single time we need to do something new, which maybe means kind of a little bit more meta level applications, or extension of Bitcoin itself, versus kind of having something that's very specific to a particular application and or use case, because at that point we're kind of picking and choosing which application is going to be done, rather than kind of giving people the primitives to do what they need to do elsewhere. But I think the main thing what they're saying right now, as far as why not do on layer 1, is basically typically there's only so many bytes in the block, so therefore you want to kind of maximize the number of transactions per byte, in a logical sense. For example, if you have a payment channel, you can kind of have that effectively compressed down from infinity to one transaction on chain whenever you close it out again.
So I just want to add, so I agree, and I think there's work that needs to be done to get to a kind of minimum viable ossification, if you like. And I think that comes down to self-extensibility, but self-extensibility in a dependable, secure way, and simplicity, which is a kind of Bitcoin scripts 2.0 design that Russell O'Connor's been working on for 4.5 years now, I think, is an attempt to do that. So at its lowest level, it's simple. And people say simplicity is not simple, but the lowest level is a kind of bit level machine with 9 operators, and anybody who's done any programming could learn exactly the semantics of those operators and be very confident they mathematically understood them. Where it gets not so simple is then you have to build everything from them, composition wise, including like a 2-bit adder and a 32-bit adder. So it's very, very low level. Then you have a collection of libraries that do common things, and you can make formal proofs about them. So at the end of the day, you should have a way to add extensibility to Bitcoin or layer 2 Bitcoin-like blockchains with formal proofs. And so the example is that with Schnorr signatures, if Bitcoin had simplicity today, you could add Schnorr signatures without a soft fork even. It would just be a script. And soft forks would be more about, adding an efficient implementation that you've proven is correct and equivalent. So, we're doing early access to this in Liquid, but I think it's interesting some years down the road as people have had more chance to think about it and evaluate and analyze the safety of this, to have that kind of formal proof-based, low-level way to extend the base layer, and then that becomes more plausible to freeze a base layer. Otherwise, I completely share Lalu's point that we saw the same thing with Lightning, and actually Lightning is waiting for an additional soft fork for.
Oh yeah, more soft forks the better.
Right. I mean, so you get into this sort of dichotomy where layer 2 is permissionless, but it's only permissionless in the sense of what you can build using the base layer, and then you run into a stumbling block where the base layer is missing an opcode, and
we need like a 5-year campaign to get the one opcode, then 5 years beyond that as well. So I think we need to consider time to time. I think simplicity is cool, but it's years off likely, right?
Guys,
so
because I want to keep the pace, because if we, but I think one very interesting point you raise is that also layer 2 innovation can go. It's a playground or a testing environment where new developments can be validated in a less risky or more contained environment, and then they can also be included on the base layer as well. So I think that's also an interesting thing. So you tested, for example, Schnorr signatures on Liquid for a while before they were implemented on the Bitcoin layer, like they are doing now. So I think that's interesting. So and I think that's a good point, because there was always like this saying about like Bitcoin not innovating, no? And I think it's like Bitcoin is innovating at the slower pace. It goes back to the ossification thing that Sergio was mentioning. Ethereum on the other side has been more about breaking things, and moving fast and breaking things. But on some things that are happening, like the CK rollups, all these emerging concepts, I think they are fascinating. So, and we all end up profiting from the research and development that all the different blockchains are building. So this takes me to, what is stopping, or what can potentiate the layer 2 development? Because we can all agree with what we have discussed so far, that second layer is a great thing because it enables us to extend functionality without compromising on security of the core layer. It allows us to scale to lower transactional costs. It has a lot of value because we can experiment and then take these improvements to the core layer. But is layer 2 really enabled, or are we missing some pieces for layer 2 development on Bitcoin and Ethereum, really take off and come to the next stage? So maybe Ola, you can start. I will ask again, sorry to be anal with this, but to speak slower because the translator, the first translator already collapsed. We are taking a new one. But, yeah.
Okay, yeah, y'all need machine translation, but okay. I'm joking. I think there are a number of things. I think for a few categories. I think one category is kind of better say cache flags, basically the ability to kind of better express what is included in a signature, basically, which can allow you to kind of have better kind of a multi-party transacting protocols. For example, I want to sign inputs 3 and 5 and the value of input 7, basically, and that's it. If you have that, I think they give you a lot of things. I think one of the very major things like covenants. So basically the ability to kind of define the restricted set of what can be spent from a particular output, basically effectively lets you kind of create an on-chain state machine, which I think is like a super powerful concept. And like right now, for like, we do that time like in Lightning, but we do it in kind of like a way that requires like one tick off-chain. We can do that like natively on-chain that like allows you for a lot of really cool things. Also, kind of like get some of that availability back the way to different protocols. One of the things, ability to like just check like arbitrary signature messages pairs. I think that'd be amazing because, for example, like that would let you kind of like delegate like a pub key. For example, like Allie could give me a pub key, I can basically sign that pub key, and then like that the contract itself would basically allow someone to like actually move the coins if they're delegated from that pub key. Other things like I guess ability to like verify Merkle proofs, actually in script itself. Basically, we kind of like have that with Taproot, but like it's kind of like very much attached. If you could do that, you can basically have a bunch of really cool things. You can basically imagine kind of have like a single output, then it maybe even shares like particular balances of an individual and all the leaves, and they allow you to do other different protocols from there. So those are like 4 things that I think if we had, that would be amazing, and I could build all really cool stuff. I'm sure other people could as well.
I share some of the needs that Olaoluwa mentioned. For instance, for RSK, TypeScript would be a great thing to increase the amount of pegnatories in the POPEG. It would allow us to go to hundreds maybe of pegnatories and reduce the size of the scripts. SIG hash no input would be something very useful. One of the projects that we are evaluating is having time lock reimbursement for the funds that the user hold on RSK in case something goes very wrong and we have to give the money back in Bitcoin. So we could create transactions on the fly as RSK goes that can reimburse the users on Bitcoin. And for doing that efficiently, SIG hash no input would be great to have. Also, covenants and virtual UTXOs also allow to scale some of our technology. One of the things that I'd love to have in Bitcoin is a new type of address that can include an op return payload. Then I could just send funds to an address and execute smart contracts on RSK. Currently, I can't do that, but I have to use my own wallet to add an op return. But what if I could embed the op return data in an address? Then I could execute any RSK transactions directly from Bitcoin. That would be great. And of course, the drive chain subfork that we've sent a couple of years ago, or any other drive chain solution would be great for RSK. These are the things that I would love to have on Bitcoin in the future.
And excellent. Jordy, can you share a little bit of what are the bottlenecks or the problems you have been facing on your work on building layer 2s?
Yeah, well, the first is we are in advantage, and building on Ethereum. Ethereum is you can program. It's a programmable blockchain, so it's very easy to build a layer 2 solution on top of blockchain. You can implement any cryptographic primitive, zero knowledge, aggregate signatures, ring signatures, anything that you can imagine. You can implement that directly in Ethereum. So Ethereum is very much like a proto-board where you can build all this stuff, and it's a very good place to experiment. Of course, you tell that before that Ethereum breaks things. I would say that, let me say that Ethereum, the core Ethereum has been breaked very, very few places, and most of them, they are not known. The community, what has been break is the smart contracts that the people built on top of that. But the core layer of Ethereum had some bugs, had been fixed, but they are very, very specific on that. And the cool thing is that in Ethereum 2.0, the strategy is to build a blockchain that's thinked very much in these layer 2 solutions, especially in the rollups. I think Vitalik is talking here tomorrow. He will explain much better than me. But one of the important things that the ZK rollups need is what we call it the data availability. And Ethereum 2.0, mainly what's going to be with all the sharding is going to be a data availability system. So in one side we have the validity proofs, which all these cryptographic zero knowledge that already are in there. Still, there is some EIPs that needs to be implemented in Ethereum for this new Plonk, Halo, and for these new curves that are appearing on that. But they are in the path and are still there. And on the other side, we have this data availability that's coming with Ethereum 2.0. And all these together, I would say there is no known limits. You know, you can with recursive snarks and this data availability with high scale, you can do as many transactions as you want, and you can scale it very much. And this is the path.
Excellent. And when you talk about data availability, you are talking about data that is stored outside the blockchain, but can be available, can be live and be consumed. That is maybe how it works.
Data availability is data that you need to guarantee that anybody have access to that data in a decentralized manner. One way to put that availability is put that data on chain. This is mainly what a lot of rollups does. They just put the transaction data in the same chain in a very compressed way. But you can use other mechanisms. For example, you can put that in Bitcoin Cash, which has a lot of space there, and then you have a proof that's in there. It's at the end you need a place. Rollups is in one side you have the proof that a set of transactions are valid, and you can put as many as you want with time constant, site reduce. You can verify that in a single transaction, but the data of the transaction data need to be available, need to be somewhere, need to be stored somewhere. People need to access.
So you need some assurances that that data will be available when you need it to validate the proof that exists on the blockchain. Okay. So
if you want to reveal the full state of the chain, you need to have access to all these data.
Adam, what do you think from your perspective, from the Liquid perspective? Maybe the things that Ola have already stated and Sergio have stated, but what do you think is like the key components missing to enable to take layer 2 from your perspective to the next level, or unleash its full potential?
Yeah, I mean, it's a bit meat in the middle. So there are multiple things that people are working on in parallel. So one is to incrementally add more opcodes, so the SIG hashes that Alan mentioned. And another such thing is simple covenants. So there's a simple covenant mechanism in Liquid, which other blockchains have copied, could be used in Bitcoin. And then the longer term track, which is longer term in Bitcoin sense, but relatively short term in Liquid sense. So we should have simplicity in Liquid Q1 next year. There have been a couple of developer releases presented at conferences over the last year or so, and you can download, have a look at it, run it in reg test with Bitcoin, and I think that's interesting because it preserves the Bitcoin stateless UTXO model, but in a generic self-extensibility way, so you can get confidence in the correctness and interpretation of the code. So you can make formal proofs about the semantics of the code, and the semantics of the code are defined, at least, right? And you can prove things about them with a proof assistant. So I think that's a robust building block for the future. But of course, it'll take a while before that makes its way from Liquid back into Bitcoin, and it depends what people think of it, right? Bitcoin only takes things if it makes sense for the central use case. But I think a modularity to allow lots of layer 2s to be built is good for sort of long-term, stability, ossification. So I think that simplicity could be a very plausible ossification step if Bitcoin would, arrive at that in a few years. That would be pretty exciting, I think.
RSK could also implement a virtual environment for executing simplicity, and we get all the simplicity apps on board.
Well, it's part of the vision, no, Sergio, to have at certain point different runtime environments live side by side. So
yes, we did a lot of tests with the different environments, but we moved with the EVM, which was obviously the most used. But yes, we did some experiments with different environments.
That takes me, as we are reaching like the final minutes of our talk, which I think we have covered a lot. It's a tough topic. it's a complex topic, but I want to add even more complexity because that's what I enjoy. So, when we talk about layers, and Adam mentioned the internet, we have the OSI model that has 7 layers, no? So we have from the physical layer up to the application layer, we have 7 layers. So is there a layer 3? I mean, we have been discussing layer 1, layer 2. Is there a layer 3? What is that thing exist? Is a mythical creature, or we have layer 3 already on the works?
Well, so there are 3 layers, but they're so far not labeled 1, 2, 3. So in the sense that it's not as widely known. I mean, lots of people have heard about Lightning, of course, but it's not as widely known that Lightning can work across multiple chains. It's a sort of caching layer that can bridge different chains. And so at Blockstream, the C Lightning implementation, which is our Lightning implementation, works on both Bitcoin and on Liquid. So, you could think about Liquid as layer 1.5, maybe, or if you wanted to make layers, you could think of the sidechain as layer 2 and Lightning as layer 3. And of course, Lalo was talking earlier about some higher level things above layer 2 as well.
We have a better taxonomy. I think this is the proof that we are building the technology. So I think the taxonomy is also being created as we move forward and create this protocol. So we might think of like Lightning running on top of Liquid as a layer 3. I think RSK also, Sergio mentioned the Reef protocols that are also layer 3. Like, what I like of these layer 3s is peer-to-peer interactions where you use the blockchain mostly, in my vision, only to settle disputes or to give an end to an open agreement environment. So I think that's interesting.
Well, in RSK, we could have also layer 4. One of the papers we published this year and the work we did about sync chains and universal merge mining allow us to build side chains of RSK over RSK. So that allows you to have still another layer, and on top of those side chains, you can have payment channel networks. So essentially, for me, it can still grow a lot in layers.
Or commit chains like the ones that Jordy is doing. So this is like kind of a mamushka of protocols we are building.
But the same way that in a network, in a communications layer, at the end we need to talk about functionality. In the case of Zk rollup, what we are solving is the throughput, quantity of transactions per second. That's the main functionality we are adding. We can add on top of that maybe a layer for latency. That would be a kind of payment channel if you want. So we add a latency layer. So maybe it would be better at some point. We are still putting in production layer 2s, okay? So talking about more layers, but at some point when we have many layers, we need to start talk about throughput layer, privacy layer, latency layer, whatever functionality, programmability layer. Any function that you are adding, it's a kind of a layer that you are building on top. Maybe it's a better way of classifying the things. We are very on time to start.
Like in the old SI model, we have transport layer, routing layer, we have the session layer. Exactly. I think that's great, because I think we are building these layers for value, because at the end we are, this is I like to call it the Internet of Value, because conceptually we are building this layered approach, delegation of concerns for the transfer of value. One final thought, because we are coming to an end of our conversation, like 30 seconds each on what excites you most of how this layer 2 and all the work you are doing will transform the space, will transform the crypto economies, Bitcoin, and the impact on the world. Maybe Ola, you can give us like your.
Sure. Yeah, I guess to answer the other thing, I think there is a layer 3 today. I would call that Lightning Pool, because it kind of like actually builds on something called a shadow chain, which is kind of like a batch processing system effectively. So you kind of already have that in production today. It depends like how you define it, of course. But I guess the main thing I'm really excited about is kind of like, giving developers kind of like, better APIs to like, move money around, like you were saying, kind of like, do so in a way that's a little bit more, generally abstracted. Obviously, kind of like the biggest thing, I think, is all this stuff in general, just kind of like how people can just like join it without like, signing up. They don't need to kind of like, give me information about themselves. They can basically start using all these APIs just as is right now, and just Ignite to continue to grow the space as right now. I think the biggest thing with all this stuff as well is obviously like, we get more people to get onto these base systems. That's kind of one of the things I was talking about a little bit earlier. The layer 2 systems are allowed generally. So I think generally kind of like, just more developer activity as far as getting more functionality, then also just like, the ability to actually onboard more and more users onto Bitcoin and everything else in general.
So simplifying the life for developers so they can be more creative and take these tools to take Bitcoin and all these tools to a broader audience. So excellent.
Mm-hmm. Yeah, because I feel like there's a lot of like pent up or like you can say like untapped Bitcoin developer energy and or excitement, which I feel like like my main thing is like how can we unlock that basically? Because I just think about all these things right now that maybe aren't really possible and or maybe people don't really have like the correct kind of like mental model to like think about like how to design these types of systems. That's like my main thing, like unleash them.
Sergio, your 20 seconds of reflection.
I've seen in especially in Latin America, I've seen the user adoption of wallets that have Bitcoin integrated with RSK, integrated with swaps between these two platforms, integrated with stable coins. And this is flourishing in front of my eyes. I mean, there was a huge change around this year. I think it's motivated because the enormous economic problems that are having some countries in Latin America, and this tendency is going to grow exponentially in the few years. So I think that the end user is going to be the one that pushes for faster and cheaper payments, faster and cheaper access to cryptocurrencies through stable coins. So these all components combined are going to be explosive in the next 1 or 2 years, especially in Latin America.
Two is enabling the conditions for mass adoption. Jordy, your 20, 30 seconds of.
Yes, we are doing this for the humanity. We want cryptocurrencies to be used by everybody in the world. I think this is a huge value for the people and for humanity. Scalability is, I would say, is one important piece. It's one of the missing pieces that we have. I think we are seeing the light right now in the layer 2. So this is something that it's going to be possible to scale. Let me remember that it's not the only one. We have also usability, security, and stability, as Sergio mentioned. But scalability is important, and this is our piece of value that we are adding to the space. But this is a trigger, because with the scalability, we can really go to each person of this world.
The layer 2 is enabling the path to mass adoption as well on the end user and by solving the scaling problems that these technologies have. So your final thoughts, and with this we'll close the amazing panel we had.
Yeah, well, I think it's behooving on us to, as technologists, to find some good solutions here, because the users are coming whether the technology is ready or not, and the pragmatists will build things using custody. So, you have PayPal now, brings a lot of users potentially, but it's all custody Bitcoin. And, there are ETFs or ETF-like products which are also custodying a lot of Bitcoins. People actually have, a database account in a share ledger in those cases. So we can do better, and with trade-offs, obviously. And I think, that there's a lot of development actually to be done, even within the existing layers, to build applications using them. So we've been quite pleased at Blockstream to see Liquid Federation members building new applications, swap tools and decentralized exchanges, all kinds of things using dependable Bitcoin-centric layer 2, so Liquid being an extension of the Bitcoin protocol. So, but for the future, I think that with more base layer extensibility, like simplicity in the future, it makes permissionless innovation faster, and it seems to me there's scope for more layer 2s with different focuses or different designs, and including some which we maybe haven't thought of yet, because there are relatively new ideas like state chains and so on. So maybe a new privacy centric layer 2 or a different scalability layer 2. So there are lots of potential in the future.
So I think, to summarize it, layer 2 is the present because it already is becoming a reality, is the future as well, is here to protect the values of what we have been building in the crypto space for many years, but also to enable this technology to take to the masses, protecting those values. So I think these efforts, this technology, it's amazing that it's happening, and thank you all for sharing your knowledge and your points of view today. So an amazing panel. Thank you, and keep enjoying La VidConf.
Great, thanks, yeah.
It's a huge pleasure.
Great pleasure.